If power factor is not used in the equation, the product of voltage and current gives a quantity known as volt amperes. In a purely resistive circuit such as one with only electric heating elements, impedance equals resistance, power factor equals 1, and wattage equals volt amperage. A few examples here should make applications of this equation clear. Power in electric circuit, the unit of electric power is watt, or is abbreviated as W, and a kilowatt is abbreviated with capital K and small letter W, is 1000 watts. Watt is the rate of power used, or represent how much is the equivalent heat volts and ampere produced if plugged in an appliances. Measure of the power consumed, potential difference of 1 volt causes a current of 1 ampere to flow. Example, calculate the power drawn using the equation. Solution, since an incandescent lamp is purely resistive and therefore has unit 1 power factor, it does not matter when the circuit is AC or DC. So resistance is 66 ohms. I equals to 1.74 ampere, and voltage is equivalent to 115 volts. In a DC circuit, we should use equation W equals to V times I. So we just substitute here the value, 115 volts times 1.74 ampere is equivalent to 200 watts. In a DC circuit, we would use equation W equals to V times I multiplied by the power factor. So it is equivalent to 115 times 174 times 1 as the power factor, which is equivalent to 200 watts. In either DC or AC circuit, we can use equation as W equals to I raised to the second power times R, which is equal to 1.74 raised to the second power times 66 is equivalent to 200 watts. The Ohm's law, the current I that will flow in a DC circuit is directly proportional to the voltage V, and inversely proportional to the resistance R of the circuit. Expressed as an equation, we have the basic form of Ohm's law, I equals to V divided by R. In a AC circuit, the same relation holds true except that instead of DC circuit resistance, we use the AC impedance. The Ohm's law is frequently written in another form, that is V equals to I times R, which states that the mathematical relationship that volts equals to currents times resistance. This form has no logical basis. Therefore, we recommend that the reader remember the form of equation R equals to V divided by R, which clearly states the physical situation, that is, as a result of voltage V, the current I is produced, that is proportional to the electric pressure V, and inversely proportional to the electric friction R. An example will illustrate the application of Ohm's law. The example chosen is applicable to both AC and DC since the device is purely resistive. Example, an incandescent lamp having a hot resistance of 66 ohms is put into a socket that is connected to a 115 volt supply. What current flow through the lamp after it reaches operating temperature? Solution, I equals to V divided by R equals to 115 divided by 66 is equivalent to 1.74 ampere. Ohm's law states that current is directly proportional to applied voltage, inversely proportional to resistance, reactance, or impedance. Formula by Ohm's law, where V equals to volts and I equals to current flow in amperes. R is equivalent to resistance in ohms. Unit of power under direct current or DC is equivalent to watts, and alternating current or AC is volt minus ampere. V equals to I times R, since P is equivalent to I times I multiplied by R, and P equals to I raised to the second power multiplied by R, and P equals to I times V. Power loss in wiring is converted to heat. A small wire diameter can safely carry more current in proportion with its weight than a large diameter wire. Thus, less copper is used to carry the same amount of power in a higher voltage current. When wire carries current, resistance of the conductor or wire will result to a voltage drop. Voltage drop is in a wire is equivalent to carried current times the resistance of wire. Power loss in ampere, I equals to wattage divided by voltage, where power expressed in watts is equivalent to volt times ampere. Formulas: V equals to I times R, or the succeeding formula, we have P equals to V times I, or we have P equals to I times R multiplied by I, or we can simplify this as P equals to I raised to the second power multiplied by R. Resistance is the friction between the flow of current through the conductor and insulator. Good conductor must have low resistance, and a good insulator must have extremely high resistance. The opposition or friction to the flow of current, resistance caused by the friction of water inside the wall of the pipe, coupling, elbow, and other forms of turns and fittings causes resistance. So resistance is the term used in direct current DC, while impedance is used in alternating current. Factors which influence resistance of a conductor: composition of the conductor, length of a conductor. The longer the wire has bigger resistance. Cross-sectional area of the conductor. The bigger the cross-sectional area of the wire, the lower its resistance. Temperature. Metal offers high resistance to high temperature. Circuit protective devices to protect insulation, wiring, bus, switches, and other apparatuses from overload, from fault or short circuit current. Example of circuit protective devices are fuse and circuit breakers. A brief glossary of the term used by electrical engineers. Alternating current constantly reverses its direction of flow. This type of electricity is generated by machines called AC generators. Ampacity is the ability of the conductor to carry current without overheating. Ampacity or ability of the conductor to carry increases as conductor's size increases. Conduits temperature increases, and it requires the rating of conductor ampacity. The rating of conductors means the ampacity of conductor is reduced a certain percentage due to the environmental condition, and the conductor is exposed, and the number of wires placed inside the conduit. Ampere, standard unit for measuring the strength of an electric current. The amount of current flow inside by 1 volt through a resistance of 1 ohm. When there is too much flow of electricity in a small conductor or wire, heat is produced in the wire, which may eventually burn the insulator, blow off the fuse that may cause fire. So Ampere is actually named after Andre M. Ampere. appliance, current consuming equipment, fixed or portable such as heating or motor operated equipment. Branch circuit is the portion of a wiring system extending beyond the final automatic overload protective device. Branch circuit appliance is a circuit supplying energy either to permanently wired appliances or to attachment plug receptacles such as appliance or convenience outlets, and having no permanently connected lighting fixtures. Branch circuit lighting, a circuit supplying energy to lighting outlets only. Bus is a conductor or group of conductors which serves as a common connection for three or more circuits in switchgear assembly. Circuit, any closed path followed or capable of being followed by an electric current. The act of following such a path, a configuration of electrically or electromagnetically connected components or devices. Closed circuit, a complete electric circuit through which current will flow when voltage is applied. Conductor, a substance that has free electrons or other charge carriers, which permits charge flow when an electromotive force is applied across the substance. Conduit is a structure containing one or more ducts, commonly formed from iron pipe on electric metallic tubing and PVC or polyvinyl chloride. Current is the rate of charge flow. A current of 1 ampere is equal to flow rate of 1 coulomb per second. Cycle is the complete series of values which occur during one period of a periodic quantity. The unit of frequency is the hertz, is 1 to 1 cycle per second. Device, a unit of component or electrical system which is intended to carry but not consume electrical energy. Example, switches, outlets, device plates. Diagram connection, a drawing showing the connections and interrelations of devices employed in an electric circuit. Direct current, electricity flows in one direction. The flow is said to be from negative to positive. Example, dry cell or battery. Electric current is the flow or rate of flow of electric force in a conductor. A current will only flow in a circuit if it is formed comprising a complete loop and contains all the required components such as source of voltage, a closed loop of wiring, an electric load such as lighting, and convenience outlet, a means of opening and closing the circuit with the aid of switch. Electrical units in the practical system. Electrical units comprise the volt, the ampere, the ohm, the watt, the watt hour, the coulomb, the mho, the henry, the farad, and the joule. Electricity is a physical entity associated with the atomic structure of matter, which occurs in polar forms, positive and negative, and which are separable by expenditure of energy. Electromotive force, or it is abbreviated as EMP, is an energy charge relation that results in electric pressure, which produces or tends to produce charge flow. Energy is the amount of physical work which a system is capable of doing. Electrical energy is measured in watt second, or the product of power and time. Force is an elementary physical cause capable of modifying the motion of a mass. Frequency, the number of periods occurring in unit time of a periodic process, such as in the flow of electric charge. Fuse element, also termed fuse links, the current carrying a part of the fuse which opens the circuit when subjected to excessive current. Fuse holder is a supporting device for a fuse that provides terminal connections. Generator, machine that produces electricity. Ground, also termed earth. A conductor connected between a circuit and the soil. A chassis ground is not necessary at ground but is taken as a 0 volt reference point, and accidental ground occurs due to cable insulator defect, etc. Guy, a wire or other mechanical members having one end secured and the other end fastened to a pole or structural part maintained under tension. Jumper is a short length of conductor or wire for making a connection between terminals around a break in a circuit or around an electrical instrument. Junction box. Number 1. Interior wiring. A metal box with blank cover for joining runs of conduit, electric metallic tubing, wireway or raceway, and providing space for connection and branching of enclosed conductors. Number 2, an enclosed distribution panel for connection or branching of one or more electric circuits without making permanent splices. Knockout, a scored portion in the wall of a box or cabinet which can be removed easily by striking with a hammer. A circular hole is provided thereby for accommodation of conduit or cable. Impedance, opposition to AC current by a combination of resistance. Impedance is measured in ohms. Insulator, a device used to insulate electrical conductors. Ions, a term applied to an atom or molecule which is not electrically balanced. This simply means that there is loss or gain of one or more electrons. Lightning rod, a rod that is run from the ground up above the highest point of a building. Motor, a machine that changes electrical energy into mechanical energy. Neutral, not positive or negative, although it may act as positive to one circuit and negative to another. Ohm, the unit of resistance. A resistance of 1 ohm sustains a current of 1 ampere when 1 volt is applied across the resistance. Outlet, a point in a wiring system from which current is taken for supply of fixtures, lamps, heaters, etc. Outlet, intended for receptacle, an outlet used with one or more receptacles which are not of the screw shell type. Outlet, intended for lighting, an outlet used for direct connection of a lamp holder, lighting fixture, or a cord that supplies a lamp holder. Open wire circuit, a circuit constructed from conductors that are separately supported on insulators. Overload protection, interruption or reduction or current under conditions of excessive demand provided by a protective device. Phase, the time of occurrence of the peak value of an AC waveform with respect to the time of occurrence of the pill value of a reference waveform. Phase is usually stated as the fractional part of a period. Plug is a device which is inserted into a receptacle for connection of a cord to the conductor. Terminations in the receptacle. Power is the rate of doing work or the rate of converting energy. When 1 volt is applied to a load and the current demand is 1 ampere, the rate of energy conversion is called power in 1 watt. Full box, a metal box with a blank cover for insertion into a conduit run, raceway, or metallic tubing, which facilitates the drawing of conductors. Raceway, a channel for holding wires or cables, constructed from metal, wood, or plastics. rigid metal conduit, electrical metal tubing, cast in place under floor, surface metal, surface wooden types, wireways, busways, and auxiliary gutters. Receptacle, also termed convenience outlet, a contacting device installed at an outlet for connection externally by means of a plug and flexible cord. Resistance is a physical property which opposes current and dissipates real power in the form of heat. Resistance is the measure in ohms. Safety outlet, also termed ground outlet. An outlet with a polarized receptacle for equipment grounding. Service entrance, the place where the service wires are run into a building. Short circuit, a fault path for current in a circuit that conducts excessive current if the fault path has appreciable resistance. It is termed a leakage path. Shunt denotes a parallel connection. Sleeve splicing, also termed connection. A metal sleeve, usually made of copper, which is slipped over the secured to the butted ends of the conductor to make a joint that provides good electrical connection. Socket, a device for mechanical support or a device such as lamp and for connection to the electrical supply. Splice, also termed straight through joint, a series connection of a pair of conductors or cables. Switch is a device for making, breaking, or rearranging the connections of an electric circuit. Symbol is a graphical representation of a circuit component also. A letter or letters used to represent the component, electrical property, or circuit characteristics. Tap in a wiring installation, a T-joint, Y-joint, or multiple joint. Three-phase circuit, a circuit delivering three-phase current. Three-way switch, a switch with three terminals by which the voltage a circuit can be completed through any one of the two paths. Three-wire circuit, a circuit using a neutral wire in which the voltage between neutral wires is twice that between neutral and each side. Toggle switch, a small switch operates by means of a smaller level. Transfer box, also termed pull box, a box without a distribution panel containing branch or otherwise interconnected circuits. Transformer, a device that operates by electromagnetic induction with a tap winding or two or more separate windings, usually on an iron core for the purpose of stepping voltage or current up or down voltage or current. Units, established values of physical properties used in measurement and calculations. For example, the volt unit, the ampere unit, the ampere turn unit, the ohms unit, etc. Voltage, volt, the electrical pressure that causes the electron to move through a conductor. In short, voltage is the electromotive force. Example, 12 volts is like having 12 pounds of water pressure in a pipe of a plumbing water system named after Alessandra Volta. Volt, the unit of electromotive force. 1 volt produces a current of 1 ampere in a resistance of 1 ohm. Volt ampere, the unit of apparent power. It is the product at the pressure time the current. Voltage drop, the difference in pressure between 2 points in a circuit caused by the resistance opposing the flow of current. Voltage loss, the voltage drop. Watts, the unit of electrical power equal to the product of 1 volt and ampere in DC values or in AC values. The rate of measure of power used or consumed. It represents how much is the equivalent heat volt and ampere consumed by the light. And appliances, named after James Watts. Wave, an electrical undulation, basically of sinusoidal form. Weatherproof, a conductor or device designed so that water, wind, or usual vapor will not impair its operation. Work is the product of force by the distance through which the force acts. Work is numerically equal to energy. So this ends my presentation.